So, we were doing this electronic and steric effects. In that the first effect we have taken inductive effect. We have defined inductive effect is a small induced polarity in a CC sigma bond on a non-polar system. If a group able to produce a small induced polarity, it is called inductive effect. It has 4 features. It is a weak effect and it is a permanent effect, however, but it has as the group goes on increasing the distance between the system and the group, the effect goes on decreases, and it is operated through the sigma bond. Based on this, one application also we have completed under the applications. One application, that is acidity, we have discussed it. Acidity of carboxylic acids and phenols, both we have discussed in the last class. So, we have studied that there is if there is a withdrawing group is there in a given acid like acetic acid, it is said to be a stronger -I group influences to increase the acidity when compared with a normal acid, and when there is a +I group, relatively when a +I group is there on a acetic acid, then it is called propanoic acid, it will be the weaker one. So, this is a stronger acid and this is acid, if I say, this will become a weaker acid. So, the acidity as the +I groups increases, either by the nature of the group, if a fluorine is there, much more acid, number of chlorines more, it is closer to this the COOH, it is more. Like that, the electronegativity of the element, number of groups, and where is the place. So, all that influence on the acidity. As the -I increases, the strength increases. Similarly, as the +I increases, the strength decreases, because the last time we have seen explanation and all that. Now, let us go to the second application, that is basicity of the amines. Ammonia is said to be a base as per the different types of the hypothesis we have proposed. This is when HCl is added, H plus is able to receive the electrons from the ammonia. So, ammonia is an electron donor in this case. All the electron donors are, in the modern theory also, we accept it as a base. So, therefore, ammonia is a base. So, it gives a ammonium chloride, a salt formation takes place. So, the ammonia is acting as electron donor, therefore, it is base now. Now, the same ammonia, we have now the one alkyl group is attached, any alkyl group. So, the alkyl group shows arbitrarily we have taken alkyl groups are +I groups. But if you come to reality also, when nitrogen is attached to the carbon, nitrogen is more electronegative, therefore, it takes electrons. So, in this example also, the alkyl really working as a +I group. So, a small electron density through the sigma bond, it is shifting to the nitrogen. So, originally the lone pair, it has a donating capacity. Now, because of this alkyl group, the donating capacity has increased. This was not there in the original ammonia. Original ammonia has a donating capacity, but increased donating capacity only you find in alkyl substituted amine. Similarly, when 2 Rs are there, more alkyl groups are there, therefore, the donating capacity, original donating capacity, added donating capacity, one more added donating capacity. So, naturally, you can explain that the 2 alkyl containing ammonia is found to be more basic. The values also refer the same thing. This is called 1 degree amine, 1 degree, that is primary amine. This is called 2 degree or secondary amine. So, we have a general statement leaving the alkyl nature. We have a general statement that 2 degree amines in general, 2 R2NH is found to be more basic than RNH2. is found to be more basic than the ammonia. This is a general statement. You can have a small differences when R changes, but in general the R2, R1 and as the number of the alkyl groups decreasing, the basicity is decreasing. The more the alkyl groups, more will be the basicity. However, you can go to the one more extent. If 3 alkyls are there, naturally we expect more basicity, but there is another phenomena called steric hindrance is coming. So, therefore, let us not take the 3 alkyls now. Now, this statement also can be shown in terms of the regular example, like methylamine is found to be more basic than ammonia, right. This is the one simple example. And even ethylamine is found to be, ethylamine means so one more carbon having, let us take a CH2, NH2 is more basic than the methylamine, right. It is also found to be the values, pKa values or basicity measurements. If you see, this is stronger to them. Even 2 methyls containing ammonia, when it is compared with either with the methylamine or with ethylamine, is more basic, and it is also with the ethylamine. In this case, alkyl group, if it is 2 carbon, there also 2 carbons are there, but here 2 carbons are directly attached. That means 2 inductive effects are directly influencing. Here only one alkyl group directly influencing, the other one is through the carbon. That means this carbon acts as a in between carbon, acts as a screen. So, the efficiency of the alkyl group on the N decreases. So, therefore, the ethylamine and dimethyl, this is directly influencing. So, the dimethylamine is found to be more basic than the amine. Like that, internal examples, number of examples you can code. Ultimately, what we are saying in this, the application is ammonia is originally base. That is not because of the inductive effect, but the basicity of ammonia, when R is there, the basicity is increased, original basicity is increased. When 2 R's are there, much more increased. So, these alkyls in general taken as a plus I, because alkyl groups, what it is attached to the groups, most of the groups are electronegative groups. So, therefore, alkyl groups are arbitrarily fixed as a plus I groups. Specifically in this example also, if a methylamine is there, like methyl carbon and nitrogen, nitrogen is more electronegative, therefore it is withdrawing. So, the alkyl groups are found to be small electron density shifted through the nitrogen. It is not total electrons. If the electrons are given away, the bond opens and you will get cation, anion. But in this case, in the inductive effect in the entire feature, you do not find the shift of the 2 electrons. It is a small electron density shift, which makes a delta plus delta minus, results in the reactivities and the stabilities difference. So, that is what we are explaining here. So, it is in general you can say that 2 degree amines are secondary amines are more basic than primary amines, and primary amines in turn are more basic than the ammonia. This is the essence of this particular application of the inductive effect on the basicity of the amines.